Hello, everyone, and welcome to this Hangout installment in our IoT Profiles series. Today we're talking with Solid Associate Chair David Cranor and Marcelo Coelho, who is the principal at Marcelo Coelho Studio. And both of them are coming to us from Shenzhen today, where they're working on the production of the alike bands for our pop-up factory at Solid. If you haven't read about our pop-up factory, I've just tweeted the link to it, to a little bit of background that David put together in a Radar article. I'll see if I can drop it into the links here in the Hangout. I don't know if that goes out to the public. But the pop-up factory is a terrific illustration of the changes that we're seeing in the new hardware movement that make it much easier to design, prototype, manufacture, and deploy physical things. The process looks a lot like the process does for designing, developing, and deploying software now. It's very flexible, it's very inexpensive, it's very fast. So David and Marcelo conceived this idea of a pop-up factory really a matter of a couple of months ago, and we're able to put the whole thing into process and to have it ready for the Solid conference at the end of June, where we're extremely excited to see it. So during this hour here that we have David and Marcelo with us, we'll start with an explanation from them of what they're doing, a little bit of technical depth here about where they stand on the project, and then we'll take questions from the audience. If you have any questions about what the pop-up factory and the alike bands entail, the easiest way to get to us is by tweeting with the hashtag IoT Profiles. That's the hashtag IoT Profiles. If you tweet a question to us there, we'll read it on air and ask David and Marcelo. So why don't we go over to David and Marcelo, who are coming to us from 1 a.m. in Shenzhen, where they've just spent the day at the factory, and hear about what they're up to.
Yep, that's about it. Hello, everyone. I hope that the connection isn't so bad through the great firewall. But I'm managing to VPN out, and we're very happy to talk to everyone. Yeah, it's been a lot of work. We basically got the clearance to go ahead with this project a few months ago, and just like really hit the ground running with getting everything together. You know, I've been to China a few times, brought John Bruner a couple times, or a few months ago, and we've come up with this idea of doing a pop-up factory at Solid, which is where we're going to set entire elements and also have a bunch of 3D printers from Formlabs 3D printing enclosures. However, at that conference, it's going to be a really great demonstration of how things get made, and people will be able to see things getting made in front of them. However, there's going to be around 2,000 people at the Solid conference, which is a lot, and the throughput of our pop-up factory is probably only going to be a few hundred. So we needed to come out here to Shenzhen in the lead-up to the conference in order to work with one of our other sponsors, Seed Studio, to assemble and manufacture and produce around 1,400 of the wristbands in preparation for the conference. So we've been here working and taking advantage of the agile supply chains and manufacturing that's available here. So let's see, I landed on the 2nd of June. Went straight to the factory. We'd already sent the design of what we're making out to them, and have been supervising the assembly of the circuit board portion of the device. The device itself, I guess I haven't talked about it yet, is a device that Marcelo's been developing actually for use at conferences. It's a wristband called the Alike Wristband, and I think it's going to be really useful for people at the show. Do you want to talk about what it actually does?
So this is the wristband. Inside of it is this tiny little circuit board, and what they do is they're always broadcasting their information, their ID, and their profile. So whenever two bands get close to each other, if they have something in common, they'll light up green, and if they don't, they'll light up red. So it's kind of a good matching social networking tool. Yeah.
But this wristband has a lot of different components. Did you bring the wristband servicing device?
No, do you have a pen?
Hang on. I got this mechanical pencil here.
Let's open this and show what's going on inside.
This guy.
All right.
So, an electronics device, a connected device in today's day and age, doesn't just like magically appear from nowhere. It actually requires a complex dance of finding electronic components, making a circuit board, finding an enclosure. If there's other accessories like a wrist strap, you have to figure out where that comes from. And all those processes are driven by different factories and different people at different places in the world. And this one we've been able to put together with the help from a lot of great sponsors. Ant Wireless has donated this wireless module for us to use in the thing. Like I said, Seed Studio is a contract manufacturer out here that does a lot of open source hardware that's been doing the circuit board assembly. Proto Labs has been generous enough to help us make a bunch of injection molded enclosures. And like I said, Formlabs is going to be coming to the actual show to bring some 3D printers to make some very special custom designed enclosures as well. So the main things that we've been working on that we've had to get sorted out in China are actually the assembly and the sourcing of the circuit board itself components. And even though we got this wireless module donated by Ant Wireless, we still had to figure out how to get the rest of it put together. So we've been working in the Seed Studio factory in order to make that happen. The other piece of it that we've been taking care of, actually today we went and took care of, is this fancy wristband part here that has all the sponsor logos on it. This is nice because it's a die-cut piece of neoprene with transfer printing on it. And so we finally finalized the design late last week. We waited a long time to finalize the design, but we got it done. And one thing that's really nice about working in Shenzhen is you can find suppliers on very short notice and get things made very fast. So, we called them, we told them, we got samples, and we actually took a hired car today out to the factory in Dongguan in order to approve the final samples, and they look pretty good. And so we're feeling pretty good about it.
Yeah, and we're basically done at this point, right?
Yeah, I think so.
A couple little things just to like wrap up and.
Yep, we finished. Yeah, we finished the assembly of 1,400 of the circuit boards, and we'll finish the 1,400 neoprene wristbands, and we're going to be shipping everything out later this week over to San Francisco.
Excellent.
We're also having another few hundred components sent to San Francisco to actually be used in the assembly process on the show floor itself, too, with Seed Studio's U.S. branch.
That's the pop-up factory that we're talking about that people can see at the Solid conference, right? Where individual sort of electronic components and 3D printing substrate go in, and completed working electronics go out.
Yeah, exactly. Sorry if we didn't make that super clear. We've been in this headspace for like a really long time. So yeah, so to be clear, Seed Studio has like a main factory here in Shenzhen where they have like a full-on factory floor. I think we've shot a bunch of video of it. We were going to try to share some of it during this hangout. And yeah, we'll share some of that. We're also going to have a fully edited version of the walkthrough of the factory later on. But like I said, to be clear, Seed Studio has a big factory out here that we're doing the assembly of 1,400 of the circuit boards, but they also have a smaller factory that includes a much smaller circuit board assembly things for smaller runs at their facility in California, and they're going to be bringing that to Solid in the pop-up factory, where we're going to be making around 250 over the course of Solid.
It's a really dramatic thing to be able to do something like this. Could you guys talk about what has changed over the last, say, 5 years that makes it possible to to develop and deploy electronics this way?
Wow.
Yeah.
Deliver your dissertation beginning now.
Yes, exactly.
I think every single part of the design process has changed, right? Starting at the software tools they use to design the hardware, all the way to these different levels of modularization of hardware. So, for example, for this device here, one of the core components is this module that Ant provided that made our design work incredibly easy. We literally just connected this module to some LEDs and a couple of other passives that really don't do a lot. A lot of the functionality is in here. And that made the design process a lot easier. But not just the design, like also the testing, because we know this works really well, and the entire fabrication process.
Yeah, so it's interesting in the sense. Hardware is becoming a whole lot more like software in the sense that it's becoming a lot more modularized. For example, like we keep talking about this wireless module. For those viewers who may not be familiar with the intimate details of hardware engineering, usually when you design something like this, you got to have some kind of brain, which is a microcontroller. You got to have some kind of like radio, which can talk to the outside world, and you got to have like some extra parts like power supplies and LEDs and stuff. But people are beginning to modularize things. So like this module that we got is really great because it includes a microcontroller as well as a radio. So that greatly simplifies the engineering process because those are two of the hardest things to like engineer. So all we have to do, or I guess Marcelo's engineer Alan had to do, who actually is the one who laid out this board. We love you, Alan. Is put this module down and then add some much more simple circuitry around it, and then we were able to package that up and send it off to the factory. So the design process was actually a lot easier for this. However, hardware still exists in the physical world, and so there are some constraints that are not similar to software in the sense of like you have to be able to get all of your stuff to the same place at the same time, and also you have to like teach other people how to make the thing that you're trying to make.
I mean, I wouldn't even go that far yet. I think the challenges are even in the design process itself, right? So a big thing is like how do you make this circuit board fit into an enclosure, like this little box here, which seems like something that's super trivial, but the reality is that it isn't. Did you just drop
I'm plugging my computer in.
So those are quite complex shapes, and the fact that we could design this and 3D print it over and over again to test it and make sure that the fit was correct and it was at the right place. It was something that you can only do today. We couldn't do that a couple of years ago, and that just speeds up the whole process, but also make I think the final design a lot better too.
Awesome. We have a very a neat little video clip that David and Marcelo managed to sneak out of China past the firewall over the weekend. It's very rough, and there's no audio under it. I took the audio out and trimmed it down to just a couple of minutes of footage. But what I'd love to do is play that for our audience, and then have you guys sort of narrate what's going on. Feel free.
Sorry if we're looking at our phones. We're watching the Twitter feed on our phones while we have you full screened on our thing. So we'll be narrating the video and also watching what people are asking. So yeah, go ahead with the video.
All right, and feel free to say pause if at any point if you want me to pause or go back or anything like that.
All right.
All right. Let me see if I can get this to work.
Is it okay to drink a beer on camera?
Yeah, we've been working really hard all day, and yeah.
It's 1 a.m. over there, so I think that's okay. All right. You guys can see the iTunes video, right? All right. Let me see if I can pin this.
So we've got the video feeds from our iPhones, but they're much larger than this wide-shot camcorder that we had, and the files for those were like way too big to be able to get through our service that we're sending videos back through. So we'll be putting like a more complete, like fully cut together version up in the coming days, because Marcel's going back to the States tomorrow, and he's actually just going to bring the files with him because it turns out that SneakerNet is more efficient than trying to get large video files out of China.
That's incredible.
That is incredible.
Yeah, there was one point where before we fixed it and got one video through, David was thinking of taking the train across the border to Hong Kong just to upload these videos on 4G. So let's go ahead.
All right, so that's the conference room where we've been set up all week. That's our project manager. Oh man, okay, yeah, pause. Pause.
Maybe that's not a good point.
Okay, so we started in the conference room where we've been working with our project manager. Her name is Vivian. She works for Seed Studio. She's amazing. She's been the one who's like handling all of the sourcing work for us. Seed Studio provides this service as a contract manufacturer where if you want to design something and you want to like have a lot of it manufactured, you have to be able to call up suppliers and get thousands and thousands of parts. And so they have relationships with part suppliers, other factories have capabilities that they don't have. You come over and you work with them, and they help you figure out how to work the social network in order to get things done. So we've been hanging out in the conference room all week, working on stuff, which happens to be right next door to their factory facility. So, of course, when you go into a factory, it's like a clean environment. It's very important that everything like remain clean and like free of to a certain degree free of impurities and dust. I mean, this isn't like an Intel like clean room or anything, but so we have to wear these funny little suits to go into the factory.
And those are mostly for static too, because if you're walking around and emitting static electricity around your body, you can discharge that on the circuits and fry everything.
Yeah. All right, you can go ahead.
Yeah, that's the thing that struck me, that strikes me every time I visit Shenzhen, and that struck me again in visiting this video. I visited a couple of different seed studio facilities in the past. They've always been just very, very clean, very, shiny white walls, very high tech, highly automated. This one even more so. It's amazing how these processes have progressed, and just how dramatically modern they look.
Yeah.
And I think kind of fun too. There was really good vibe there of like a lot of colorful stuff and
yeah, everyone enjoying what they're doing.
Kind of creative things around the space. It was really cool.
All right, so here we are getting ready to go in. Vivian's about to say, "Come in and check out our factory." So yeah, so this is the floor. So right here, this is the board. The way that Seed organizes their factory workers is they're all organized into subgroups. It's not just like a line of people sadly sitting and like tweezering components into place over and over again. The workers at the factory are actually organized into groups, and every day they put up on this board like what needs to be done for the day. And each subgroup of workers picks a task, and then they split up the subtasks among themselves. So it's like, oh, okay, we need to make these alike bands. Okay, sweet. Well, I'll do I'll do the hand soldering. I'll run the reflow. I'll do the testing. And so it's all very dynamically allocated. I think that's what she's saying right there in the video. So our first stop here is actually on the assembly line. They call it an SMT machine. An SMT line for surface mount technology. So the types of parts that are on these boards, there's like two main types of electronic components. There's surface mount components, which are ones that are just soldered directly to the surface of the board, and there's also through-hole components like the battery clip, which actually have a wire that goes through the board and is soldered on. So the first step in the process is where they actually get the boards and they put them into this machine that stencils solder paste onto the empty pads of the boards, which is literally, it's exactly what it sounds like. It's a paste that contains microscopic balls of solder that are suspended in a flux, and so it goes and there's this giant automatic stencil that just goes chunk chunk and like puts the things on.
It's printing, right? But instead of using paint, you're using solder.
Yeah, exactly. So I think there's some video of that here.
We might have to get the video of the machine itself out to the audience a little later.
Oh, I see. Okay. So I'll just describe the process. So pause it real quick. So basically, so the board comes in, it goes into the stenciling machine. The board comes in, the stencil comes down, and then like a big squeegees scrapes the solder paste against the stencil, and then there's like little squares of solder paste on every single place where a component goes. Then after that, it continues on down a little conveyor belt and goes into what's called a pick-and-place machine, which is where they load reels of components. So these little components here, these tiny ones that I keep pointing out, they actually come on these reels that you're seeing on the screen right now, and it's almost like a film strip reel or something. It has like a little hole for a sprocket, and there's just like tons of little components, and they load these into the pick-and-place, and then there's this automatic head that like goes and picks them up with a little vacuum and like puts them down all over the boards onto the freshly laid down solder paste. And then after that, it goes into this what's called a reflow oven, where there's like many temperature zones. It's kind of like a pizza oven at Pizza Hut, where it like kind of goes through because the solder requires a very specific temperature profile in order to like heat it up and then melt it and then like cool it down so it doesn't crack or do anything bad. For example, if anybody out there remembers when the Xbox 360s were doing the red ring of death a few years ago, that was an issue with poor soldering profiles and temperature tolerance because the whole box was heating up and it was like cracking the solder that was connecting a very important chip on the motherboard. And so when you're soldering, it's important to have very tight process control. So it goes through. So to review, the board comes in, solder paste gets stenciled on, pick and place, puts components onto it, then it goes through this pizza oven and it melts the solder on.
And those are, by the way, those reels here that we just saw. as we walked by. These are reels of electric components, right? Of tiny surface mount components.
Yes, yes, those are surface mount reels. So then the next step we can see here is after the surface mount components are placed, it actually has to go to a manual process to get the several manual processes to get through-hole components on. This is not the alike bands that we're looking at here. We'll see the alike bands later, I think. This is like a different board that they're working on in the factory. Because when we got there in the morning, it was kind of funny actually. They said they were going to start at 9 in the morning, and our taxi got stuck in traffic, and we got there at 9:30, and they're like, "Oh yeah, we've already put all of your 1,400 boards through the SMT line, and so now they're on the hand soldering. We can't take pictures of that because we have other stuff we got to do." And so they're working on some other thing here.
And I think that's kind of cool to talk about a little bit, right? Because the stuff that they couldn't do in that an hour, thing they had to do by hand.
Yeah.
So a lot of the design decisions they also make really play a big role that takes as well. I think that was a big lesson for me, right? And looking at the ways it was designed, sometimes because you think it's the best component for the kind of functionality that you have, and how the stuff is going to be assembled, and it's really important to think about it and understand how that process happens.
Yeah, so this is a dip soldering station. This is where they're putting through-hole components that have long wire legs through the circuit board, and so they don't you want to try to avoid doing as much by hand as possible. You want to do it in as batch as much as possible, and so basically they put through-hole components through the board, and then they just dip it into a vat full of molten solder, and it heats up the legs, and it just kind of like sucks the solder up on and solders on the other side.
All right, restarting the video here.
Yep.
So those are stacks of someone else's boards. All right,
yeah.
And what's this?
And after
Hold
those
on, David, you might. Your audio is getting a little scrambled. You might want to turn off. Sorry, you might want to turn off your video for a moment to conserve bandwidth. Your audio is getting a little scrambled.
Can you hear me?
Try again. Yeah, go ahead.
Okay, so that's the circuit board washing area. So basically, those are just machines that they put the circuit boards in after they've been through the reflow line to just like clean them off and just like get any gunk or impurities off of them before they proceed to the next steps in the process.
Yeah, what happens to when you melt the solder, it kind of like oozes off this flux, and those tanks clean that stuff off. Flux adds a lot of resistance to the circuit, which might interfere in the behavior. Yeah.
All right, now we go on to, is this one of the assembly lines?
So this is actually a hand soldering station where they're soldering the actual battery clip of the alike band main PCBA assembled printed circuit board onto the board, and they have to do that by hand because this is a type of component. I don't know if you can go back to my video. Will people be able to see me if I turn my video back on?
Yeah, I think so.
So you can see this battery down here. Like this has legs that goes through to the other side of the board, but you can't dip it from this side because we've already put components on this side, and so it would mess it up. But you can't dip it from this side either because then you'd fill this whole part with solder. So this actually is a component that needs to be soldered on by hand. So that's what they're doing here.
All right. How long does it take to solder on a single component by hand like this?
Like a couple seconds. They go really, really fast.
Yeah, they do them in this batches of I think they had like maybe 12 boards or something.
I forgot how big the panel was.
They basically have like a little rectangular panel with a bunch of boards, and they do those little batches together. The reason for making the panels is that it's easy to put those into the machine, but then they kind of become this sort of unit of assembly throughout the entire assembly line.
Yeah, so it makes more sense to put them together in a lot of squares. I'm gonna turn my video back on. So it makes more sense to instead of doing one board at a time, you put them together in a panel, like tuck, 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 and then you do assembly of lots of them in parallel, and then you break them apart at the very end.
Yeah, it's like a
All
chocolate.
Right.
Yeah.
So here's testing.
Oh, you should talk about testing.
Oh man. Yeah. So basically, what he's doing there is he has this little lever, this red lever, where you kind of bring it down, and a series of electrical pins will go down and press into the board. I show you
test points.
This little where is it? Focus camera. Oh, there you go. Kind of. Okay, right there. There's this little metal pads, and those are for programming the circuit board. So basically, he lowers the pins into that, and then he hits a bunch of buttons on the computer screen to download the program. And then there's a test routine where there's another little board sitting on the table that he can turn on and off. And when he does that, he communicates to the board that he has just programmed, makes the board go through a sequence of light colors, and then responds back, and then the board that he just turned on changed color. So that entire process takes about, what, like maybe
30 seconds.
30 seconds or something?
But 30 seconds times 1,500 boards is like a day.
Yeah, and it's funny too because like when we were designing this at the studio, we thought that was a pretty quick test process, but that took an incredible amount of time. It took really, really long.
Yeah, I mean, like they did all the entire run of the automated stuff, of the SMT, of the soldering of the tiny stuff, like, you know, in a morning for our entire run of more than like 1,000 boards. But then it took 3 days to like do the entire programming and test process because it takes 30 seconds per board. And so like one thing that hardware startup, you know, that everyone complains about in China, actually, I don't know if there's anybody from hardware startups listening to this right now, that people complain about, is that an often overlooked part of the manufacturing process is the actually the testing process, because people, you know, come and they're like, okay, here's my design, like make my design, these are the components that I want, sweet, put it through the reflow, and they're like, okay, what's your testing assembly process? And they're like, oh, well, you know, like I have this like Unix tool that I use, you need to like load it up, you need to add this command and add this flag, and then you push this button and whatever, but like every single second that you save and like plan about that process saves you tons of time. So like even if it takes you a minute to flash your firmware on your prototype, that is just going to totally kill you in manufacturing. And so you really have to think about like making, you know, a process for putting the stuff onto the board and for testing it that like a technician in the factory can literally just push a button and look at a light and see if it worked or not. And that's something that one has to develop that people often don't think about.
Yeah, it's sort of the engineering of the manufacturing process and making it extraordinarily efficient.
Yeah, I mean, you have to think about all this stuff. I mean, the product itself.
And you have to think about it early on. Right?
Yeah,
you have to think about it when you're designing the product. You can't really design the product and wait until you're done to think about how it's going to be manufactured.
Yeah, like the product itself, you know, is just the fruit, you know, of this like entire tree, like
chain
garden of chain that has to be like cultivated and grown, and like you have to think about everything around it. And I mean, like when you get the product at the end, it's like really nice to have, but if you're actually trying to design something, you actually have to plan very carefully everything that goes into producing it.
So how much of that, I mean, you know, the testing process, did you guys have to develop yourselves versus, you know, Seed coming up with after you gave them the design for the circuit boards?
So all of it.
Yeah, so I mean, we developed the software part of the test, and they developed the hardware. But we talked a lot with them about how we're going to integrate our programmers and our software to their hardware. Yeah, and we learned a lot of lessons about how to do that. I think if we were to do it again, we had some pretty good ideas of how to change it to make it quicker.
I mean, basically, we gave them the circuit board design, and we said there's going to be test points here that are going to be to a programmer, and they said okay, and they made the test jig. You can see that test jig with the little red lever that like clamps the pogo pins down. But we actually had to bring physically into the factory. We had to bring the like actual device that programs the microcontroller. We had to bring on a flash disk, the actual programming software to program the testing controller, so that they could load it onto that computer. We had to help them connect it to the test jig and show them exactly, you know, what our program does, and we had to be like, you know, you push this button, the light will turn red, green, blue, and then you shake it to make sure that the battery isn't going to fall out. And we actually had to like work with them to define that entire testing program so that they would know what our requirements were for having a valid design come out.
Yeah, and one thing that's not very obvious, for instance, right, is that so right now you can see there's two jigs on that table. There's one of the guys operating, there's one right behind David. But you can't run two right next to each other because they're using radio to do the test. So if there's two people testing at the same time, they're going to interfere with each other. So that was right in the beginning, and they realized they're having problems, so they had to move one of them to another floor and then redo some of the tests.
Yeah, so we had one on the second floor and one on the fourth floor.
Yeah, so you're not just testing the stuff you're testing, you're kind of testing that room that has all this other stuff in it that you have to think about too.
Yeah. So let me play this and sort of narrate what's going on. He has the board in the jig right now. He's taking it out, and now he starts shaking it. Is that to see if he can loosen any of the components?
Yeah.
Test the glue.
Just make sure the battery is properly. Yeah.
All right.
There's a little bit of solder in the back of the
circuit. Into the jig. Yeah.
Yeah. Let me make sure that the battery is tightly connected. Yeah. There you go.
Cool. All right.
Because it's like, we don't want to have a problem where, like, people are wearing these wristbands and, like, moving around and all of a sudden it turns off because, like, maybe the battery, like, moved a little bit inside the clip. And, like, that's the kind of thing that you have to think about when you're actually at the factory. So it's literally like, tell the guy when he finishes flashing the firmware to, like, pick it up and give it a good shake and make sure that the light stays on.
All right. Now let's go back here and mention that Seed Studio, as you can see from the giant maker robot, is one of the founding hosts of the Maker Fair Shenzhen, which is an interesting expression of this movement that you can see in China, where this is not only the home of the agile manufacturing that plays a role in the new hardware movement. It's also increasingly a home to a lot of the creative stuff and the innovative stuff that's behind that as well. A lot of higher level design and engineering is happening in Shenzhen, right next to the factories.
Yeah,
so
it's really interesting because. Oh, sorry. Go ahead.
No, go ahead.
I was just gonna say it's interesting because the whole sort of ethos of the manufacturing stuff in Shenzhen, like, really meshes very well with the whole maker thing. And so Seed Studio has really been able to, like, capture all of this infrastructure that Shenzhen has had since the 80s and, like, harness it together with the inherent creativity of the maker movement. And, like, they're working on, like, bringing it up to the next level of, like, beyond, look at all the horrible things that I made this poor little, like, Arduino do, to how do I take my thing that I made and it's just me using some open source hardware and software and, like, manufacture thousands of it to share it with the world. Maybe I'm not going to manufacture 10,000s of it, but, like, how to manufacture things in the thousands is actually kind of a hard problem right now, because it's like you can make one prototype by yourself, you can get, like, your friend to help you make 10 of something. If you stay up really late for, like, a week, you can make 100 of them. We don't know where you go to make 1,000 of them because economy of scale doesn't really kick in until, like, you're, like, a big company and can afford to make 10,000. And so one thing that Seed Studio is really trying to figure out with their whole Agile Manufacturing Center, that's what they call their factory, is kind of addressing things in, like, the 100s to 1,000s range. And so that's why this Alike Band project is really perfect for Solid, because it's a product that's super useful for deployment of several thousand people. We're not trying to sell it to 100,000 people right away. But we still want to use it. We still want to use it at the conference, and, like, we're just now kind of getting to the point where the manufacturing processes are allowing us to be able to do this in a cost-effective kind of way.
This is all right. What's this step that we're walking up to here now?
That's just that's sort of into the process, like quality control and packaging. They're just, like, putting everything into bags, anti-static bags for shipping out, and, like, making sure that everything, nothing is wrong, the silk screens on everything look good, the lights are lighting up the way that they're supposed to, nothing is obviously broken, like, stuff isn't falling off, wires aren't falling out. It's just kind of like the final quality control and packaging up process before they ship it out.
Awesome. And then talk about how these are gonna make it to Solid. I mean, these are the boards going into packaging. They're going to be FedExed to San Francisco.
Yeah, we're having 3,000 injection molded parts shipped from Proto Labs in Minnesota to to the O'Reilly Alpha Tech Ventures office in San Francisco. We're having.
Sorry, and just to explain quickly, I don't think we mentioned this, but Protolabs is making Enclosures, which are these injection molded enclosures for the band.
Yeah, there's two different kinds of enclosures. Sorry, because we're also trying to make a point about how like large scale manufacturing is coming down in like availability. So like previously, usually injection molds only practical for like tens of thousands of units. Protolabs has developed a really awesome software tool chain to allow you to make injection molds for like thousands of units, which is a big deal. On the other end, 3D printing, historically has only been used for like sort of 1 to 10 prototypes, but companies like Formlabs are able to get you more into sort of the hundreds of prototypes range. And so we've got Protolabs making the enclosures for like most of the wristbands, but we also have Formlabs who are going to be there making several hundred like custom computationally generated wristband enclosures, and so people will be able to like customize what their actual device looks like. So to finish the story, we're having the injection molded part shipped from Minnesota to the O'Reilly Alpha Tech Ventures office in San Francisco. We're having the 1,400 assembled circuit boards shipped from China tomorrow, hopefully, to the O'Reilly Alpha Tech Ventures office in San Francisco. We're also going to have the test jigs sent as well, so we can use those at Solid. Marcelo and I are actually going to meet up at the O'Reilly Alpha Tech office in San Francisco, and we're going to take over a conference room there and do the final assembly of the bulk of the things. And then we're also going to work with the Seed Studio office there to get their smaller reflow lines set up in the main part of the expo hall in order to show some more circuit board assembly with the smaller machines.
This is I will be working from home rather than in my office for the days immediately before Solid.
You're going to help us
entirely.
Yeah, you're going to help us assemble wristbands. What are you talking about?
You don't know anything about it yet, but you're assembling.
Wear
a hat.
Awesome. Well, as long as I can wear a hat. Will it be pink like the ones in the factory?
We'll make it pink.
Does Seed have color-coded factory uniforms like some of the factories in Shenzhen?
I don't think so, but it seemed like the loaners were pink, and the ones that most people wear there were like the people who actually work there are like white and yellow.
Interesting.
Yeah, but it wasn't like colored by zone or anything. It's a pretty, it's a really well-run factory. It's pretty chill, yeah.
And here we go back through the dust curtain, and that's it for the initial footage that you guys snuck out through the firewall. So we'll, as David mentioned earlier, we'll have a larger, more complete video. As you can see, David and Marcelo are also taking video footage. It's all going to be synced up, and the result will be probably more like a 10-minute video that walks through the entire process, showing how these things are being made in China. It's really incredible. I mean, you mentioned the fact that you had like found things, especially in the testing process, that if you were to do them over again, you would do differently, which is kind of how like software engineers talk about the back end for a website or something. We put it together on short notice, we learned something, and we'll do something different next time. But that's not something you hear about in hardware, or something you used to hear about in hardware as like a little thing that we'll do differently next time we learned about it because we went to the factory, and we'll be able to change it.
Yeah, and I think I have to think more about this and reflect a little bit on the entire trip. I mean, I've been here for maybe 4 or 5 days now, and it really has changed the way that I think about how things are made. It has been pretty incredible, actually. I think one of the big lessons is that it's really hard to be in Boston, where the studio is based, designing, without really understanding how all this stuff works, right? I think the reality is that, and if it was possible, you really want to come here. You want to be here for a month, and you want to design and be in really close communication with the factories to be able to make your stuff, because they're really good at it. They really know what's possible. They really know what's not possible. They know how some of the design decisions that you make are going to affect the different things that you can or cannot make, and those are things that are hard to know. It really depends on all the machines you're going to use and where the materials come from and all that stuff.
Yeah, like it just really helps to know like what you have access to, and working with people, and like being able to work with people in person is really important.
We're stuck with like a good example. Yeah. Like we went to this factory today, So this is the strap that's part of the wristband. So it's a neoprene strap, and it has this printout here for the sponsor logos. And it's really interesting because we spent a lot of time in the studio trying to figure out what the right shape for this was, so that we could accommodate different wrist sizes. And we have wrists, big wrists, right? So we made it stretchy, figured out the right shape, and blah blah blah. So anyway, we send this chip to a factory, and we send the shape design, and we get there, and we look at it, and we try to stretch his the design that they made, and he only stretched maybe about 50%.
Yeah,
of what the original stretch was supposed to look like.
Enough.
And it was super hard to explain to the guy, what we were trying to get to. And then we showed our prototype and said, hey, this is what we're trying to do, and he stretched it, and he's like, oh, I get it, because you're using 100% neoprene, not 30% that I used. And then we got the problem solved.
Yeah, and he was like, hang on, I'll be right back. He's like, I'm glad you showed me this, because Marcelo had prototyped just using neoprene that you ordered from like McMaster Car or something, and then did all the stretching. But then we just sent a photo to the guy in the factory, and he didn't know like the physical properties of it, so he just did it using what I had. He made a good guess at it. But like we went out there to actually sit down with him and see it, and then we showed him the prototype. It knew exactly what we were talking about because he runs a freaking neoprene factory. And he was like, hang on, I'll be right back. I'll get some more. He ran out of the room, came back like 10 minutes later, gets the die tool that we'd made and clamps one out, and he's like, all right, try this. And it was like exactly the right stretchiness. That process, if we'd been driving it from the U.S.,
it
would have taken a month because like he would have sent us prototypes, we would have tried it, oh, it's not good enough. We would have had to like email with him and like describe how stretchy it needs to be. He would have had to go try something, then we would have had to wait more time for him to mail something to us, then we would have had to feedback more. But we got it all done in the space of like an hour just because we took a car out to Dongguan to the factory where the guy and his machines were, and we were able to just like sit down and have a conversation.
David and I visited Matt Jones, right, at Google, perhaps a year ago, and he used this phrase that really resonated with me. That's manufacturing as design input. The idea that if you understand how the manufacturing process works, it becomes an inspiration for the design. You can understand it not just as a constraint, but as an expanded possibility set, because you know what is possible, and you're working in the kind of the full envelope of possibility.
But it's really interesting too. Like as a designer, when you go to design school, you learn design by making stuff. You never really think or learn about how to do things at that scale. I think there's all these little like details of processes and ways that atoms get moved around and shift and pulled and cut that you only really get when you're on the factory floor. And I think that's kind of somewhat a missing gap in the kind of education design processes that we have today.
Yeah, because it's really important to know what there is, right? Like if you sit down and you're like, okay, I'm going to do a startup, and I want to make a handheld device that has a screen on it. It's going to be 5.2 inches, and it's going to have this resolution, it's going to have this enclosure. Like, you're going to be screwed if you, like, want to go out and, like, try to get a custom LCD made that's, like, exactly that dimension, exactly that whatever, because you're just a small organization. What you have to do is you have to think about what are all the other factories making? What processes are there in place? Maybe you can just go to the market and buy a panel that's already being made for, like, an Apple or a Samsung product or something that the factories have already figured out how to do, and you, like, design your product around that. And, like, it's not bad to do that. It's just like something to take into account when you're thinking about what kind of experience you want to get to your users, but also how to get your product done in like a cost-effective and expedient way. You got to be aware of like what the actual tool is going to be that's making it. And also then with respect to the testing process, one thing that you have to remember is if you're making something, it isn't just entirely automated. Like there's people who you have to explain to how they need to be doing this and why they need to be doing it. And so, like, you got to remember, if you are trying to design something that's going to have, like, thousands made of it, you have to design something that you can easily teach someone else how to make as well.
Mm-hmm. I'd love to go to a question from Twitter, but first, just a reminder to the audience that if you have a question for us during the Hangout, you can tweet with the hashtag IoT profiles. And we'll try to take it in the remaining 10 minutes here. A couple of people have asked about the radio that you're using here. Is it Bluetooth Low Energy? what are the protocols that you're dealing with?
So there's two protocols. Actually, the primary one they're using is not Bluetooth. It's the Ant wireless protocol, and that's what you're using for the device to exchange profiles and communicate with each other. Although the radio that we're using also supports Bluetooth, and we picked that radio so that we could have the radios talk to each other, but also have them talk to your phone.
Yeah, and it's interesting because, like, technologies like Bluetooth and wireless are in a lot of devices right now, but sometimes people try to push them to do more than they were originally designed to do. Excuse me, I said Bluetooth and Wi-Fi is what I meant to say. And technologies like Ant Wireless are much better for doing like mesh networking than Bluetooth. Bluetooth is much more about like you have a central thing that like has a little cloud of things around it in a network like that. But this type of device is something that is meant to just communicate ad hoc with other things in kind of a mesh networking kind of way. And so the Ant Wireless protocol is much better for that. And so that's why Marcelo chose to use it for that.
Yeah.
But like we said, this module is awesome because it does both of them. So you can like use it as a bridge to your mobile device for Bluetooth, and then you can also have it talk to like lots of other devices over the Ant Wireless protocol.
The other thing that's really important to mention too is that this has to last for a long time, right? So the conference lasts 3 days, and once you give this to somebody, it's on for 3 days. So this radio is very low power as well, so we can make sure that we can have like a really bright LED on, and it is super bright, and have the radio broadcast at the same time for 3 days, which is super cool.
Earlier, when we were trying to get the lighting right in the room where David and Marcelo were sitting in Shenzhen, they were switching on a handful of the wristbands to try to illuminate themselves with the light bands. So, and how? Tell us a little bit about the software that's running on the bands. Is there actually an operating system running on it, or kind of at what level are you programming them?
I mean, pretty low, as low as you could go before you go down to assembly, I would say. I mean, it's at a point where we're actually creating, we're kind of building our own protocol on top of the Ant wireless protocol. And while their protocol does a lot with network communication, things that you have to think about, we're really thinking about profiles and how do we send these little bits of data to describe people so that we can pair them up and find ways that they correlate with each other. And there's a lot going on. Like it's really cool because we're actually always listening. So whenever one of these is on, it's actually listening to all the other bands that are around it in a like maybe about 3 meter radius, and it's constantly deciding what to do with all that information. Whether they should match with somebody, or should just be watching somebody until they approach them. So there's a lot of really cool stuff going on.
Awesome. Tell us about how the manufacturing process on the floor, the pop-up factory that you're putting in at Solid, is the electronics manufacturing process there going to be fundamentally different from the one that you're using in Shenzhen?
It's just going to be smaller. So because the one in Shenzhen, uses full-size factory floor equipment. One interesting thing that Eric Pan, the guy who started Seed Studio, is interested in doing is kind of, like I said before, like bridging this gap between makers and like people who are shipping products. Because I mean, makers obviously want to do that, and so there's this whole line of like smaller desktop-size pick-and-place machines and reflow ovens. We're getting desktop milling machines, we're getting desktop 3D printers, and I think a lot of people in the U.S. have heard of both of those. Through companies like Formlabs, MakerBot, other machine company, like whatever. But there's also like smaller, actual assembly mechanisms coming out of China as well. And so one thing Eric is doing is he's setting up like some little manufacturing centers around the U.S. Which have these like smaller versions of the assembly line stuff, where people will be able to come and like work with their staff to make sort of 50 to 100 units of something. And so because it's a pop-up factory and it's small and it's instantaneous, we've set aside a 20-foot by 20-foot space where we're going to have desktop pick-and-place machine, desktop reflow oven, a little soldering station to put that battery clip on, and then we're also going to have a wall of 12 Form 1 Pluses from Formlabs making those custom-generated enclosures on the fly. So it's going to be like the same fundamental technology, but sort of the more like distributed, agile version of that.
Excellent. It's incredible that you can like set up this kind of manufacturing on the with portable machines and churn out the stuff.
Well,
Obviously, the volume is going to be lower.
I think this is the first time they ever tried to do something like this at a conference. So this is like a pretty exciting experiment for this. I mean, I think it's going to work, but also we got to make sure that we do it right.
No, it is pretty incredible though. Like we had a dinner tonight and we were talking about that. Like years from now, we're going to be able to do all the single machine desk. What happened for the entire manufacturing process? You know, you can do the enclosures, the circuit boards, the whole thing in one shot at your desk, and it is really happening. It's not a pipe dream. It's not hyping. We're seeing it happening right now.
Yeah, I mean, there's so much more that goes into the making of a connected device than just a piece of plastic that's made by a 3D printer. And so we're seeing all the other pieces of the supply chain getting miniaturized and modularized as well, and that's like super exciting to be able to bring that out so that people can come into our conference and like look at it and see what it actually looks like. Like, I mean, we're going to be able to see, like, you're going to come to Solid and you're going to see reels of components like capacitors, resistors, like wireless modules going through an assembly line and like being turned into devices that light up and that they hand to you and then you can then go and use. It's like you're seeing these things actually being born. You're getting a look into the kitchen of how these devices are being cooked. It's really exciting.
That's amazing. I'm so excited to see this all come together. My pen just burst as I shouldn't play with pens, I guess. I'm a little distracted. But it's an incredible testament to to how far this stuff has come, that you can watch this stuff get made, and you really started to prepare this this demo, the pop-up factory, and plan it out in detail only in April, right? Or I think it was like mid or late April that we decided to go ahead with it and give you the floor space for it.
Yep, that's true. And thanks to our amazing sponsors and their amazing capabilities, we've been able to pull it together. Marcelo is the one, him and Alan are the ones who really designed these wristbands. But being able to take it to scale, just the design and also the taking to scale, it's not something that two guys would have been able to do until fairly recently. This is a pretty complex device. It's got a radio, it's got a microcontroller, it's got passive components, it's got an LED, it's got an injection molded enclosure, it's got a 3D printed version of that enclosure, it has it has a neoprene wristband. But because of the modularization of all these technologies, we're able to take advantage, dynamically allocating lots of other organizations that have spent lots of resources, basically into a physical API that you can just take and put into your thing, right? I mean, like I was saying earlier, Marcelo didn't have to lay and design an entire antenna and radio. He didn't have to, design the microcontroller part. He was able to get the module from Ant Wireless and put it onto his board and add an LED so that they could focus on making nice user interactions. Previously to make an injection molding tool, you have to have a fleet of mechanical engineers who know about mold flow and plastic flow and
just like this black.
It's like this black magic art. You have to go to the factory. You have to allow the tool, the mold itself. That's what we call, something used to do injection molding is you call it the tool, is the mold. So you'd have to go and mill it. You have to test it. You have to shoot plastic into it. See, fix it. Proto Labs has developed this amazing piece of software where you just go to their website and you upload your design and it does all the mold flow analysis for you and tells you this wall is too thin, that's going to break. This other thing is going to work, and they quickly turn parts for you really fast and get it done. So they're helping us out with that. Before you'd have to go and call up and find a factory and find part suppliers and do all this other stuff. Seed Studio has spent a lot of time building a supply chain, building a factory floor, working with Western companies so that we can just go there and bring them a design and give them a bill of materials, and they go and find it for us and figure out how to get it done. So it's really this ad hoc dynamic allocation of tons of different technology allowing us to put something like this together so fast.
Right. It's I love this idea of the physical API that in exactly the same way that software APIs work, it encapsulates something very complex into an interface that's really easy to use. So it's it hasn't gone quite as far as like Lego electronics, though you already see signs of that in prototyping tools like Little Bits. But when you look at these, the wireless modules in particular that have come out from ANT, whose module you're using, also particle, electric imp, and so on. Just the speed that they enable for is incredible. I think this is creating kind of a full stack hardware engineer in the way that you have full stack web developers who know everything about the databases and back-end stuff at one end to the JavaScript and HTML and CSS on the other, and they can develop full applications. It's impossible to imagine a full stack hardware engineer being able to do really big things and working quickly 10 years ago before all of this modularization and the physical APIs that come out of this stuff. But now it's possible. I mean, the two of you have been able to make this come together in a matter of a couple of months.
Yeah. So I mean, important point to make about all of this is that like it's not just the two of us. It's like we have this network of amazing people, technologies, and it's fun because through the process of putting together the solid to know all of these companies, and we go enough money to sponsor so we can put their logo up on the website, and like we talk everybody and we talk about how exciting all this new stuff is, but it's been like a really great example of like being able to actually work with everyone and actually like do it for real.
Well, and I think the hardware API is not just this abstract tool, right? It's also people. The people kind of formed this hardware API that allows us to make stuff, and being able to communicate with them, like the example they were given before of having this neoprene band and being able to sit in front of somebody and say, hey, we wanted to stretch this much. I think that's part of the process, and I think that having better ways to communicate and better tools and better processes will enable that to happen. And I think that's kind of what's cool to think about. What are the things that we need right now to make that easier as we move forward?
This has been an incredible conversation, and I think that what you guys are working on is going to be an amazing demonstration of what's possible here at the horizon. This is going to have an impact not only on kind of agile, quick startup type things and fast deployment projects that are one-off, but also on the enterprise side, you hear big companies talking about being able to use the kinds of tools you're using to develop, pretty heavy-duty enterprise systems very quickly. They use different backbones and different kinds of infrastructure, but yeah, we're calling this the new hardware movement. I think it's bigger than the Internet of Things, as we've been tweeting out, over the weekend, and this is a terrific illustration. So, thank you guys so much for your work on this.
Yeah.
Thanks,
thanks for letting us do it. We're really excited about it.
Yeah.
Awesome. If you want to come and see David and Marcelo and their pop-up factory at Solid, you can register for Solid with a discount code, HANGOUT, all caps. Yep, David has it on his screen right now. Now there's a low battery notification. You guys are doing all of this over wireless from China. So use the discount code HANGOUT for a 20% discount on your Solid registration. Go to solidcon.com to register for the conference and to see the pop-up factory there. David and Marcelo and Mung from Seed are all going to be speaking about the project that they're working on, how they did it, and what it means for the new hardware movement and the Internet of Things. So thank you so much, guys. It's been a pleasure, and good luck with the rest of your visit to China.
All right, we'll see you guys. We'll see you at Solid.
Take care.
See you at Solid.